Assalamu alaikum wa rahmatullahi wa barakatuh. Hi guys, my name is Ali. Today I'm going to show you how you can create your urban heat island map using Google Earth Engine. So before moving to code, first of all I want to show you the formula that how we will actually calculate our UHI. So here I explained that we have to subtract first of all LST from LST mean, then we have to divide it by standard deviation. So here I explained how we will do that. Here I explained that UHI stands for what and LST stands for what, and how actually I designed this formula to reach the main goal. So our main motive here is to get the urban heat island map. So here's the formula that we're gonna use. So here I just explained that how it will work. So after doing that, first of all I defined a variable, actually my study area, which is Karachi. So I'm going to perform this analysis on Karachi, and after that I explained the start date and end date. Here's the main thing that I applied June and July because these are the like hottest month over here in Pakistan. So in your case you have to set the values according to your region. For example, if you are from another region, so there might be different months that can be hotter. So I selected these 3 months which are considered hotter. So here I'm showing you that I got this urban heat island map. I selected the hottest month over here in Pakistan, which are June, July and August. So for that range I selected this, and here you can see urban heat island map, and I calculated land surface temperature and urban heat island map, and here you can see in the result. And here I got maximum and minimum value, in which maximum value indicates that there is probably urban heat effect, or you can sense that urban heat intensity. So this was all about we get all the values printed over here in console. So by these values we will be able to generate our final map. Now let's move to code. So here I explained that how we will use this formula. So first of all I loaded my area of interest, then I selected hottest month over here in Pakistan, which are June and July, and August is considered like normal or little bit warm over here in Pakistan. So after that we have to pre-process our Landsat image. For that I applied scale factors and a function, like a function that filter Landsat 8 images based on cloud cover pixels with cloud or cloud shadow based on specific. So our next step is the pre-processing Landsat 8. So where I applied the different functions, like I applied scale factor. The scaling factor, actually this function applies scaling factor to optical and thermal bands of Landsat 8 image for continent units and interpretation. Then I applied function to for cloud cover pixels with cloud or cloud shadow based on specific bit mask are masked out to ensure better data quality. And here's this selected one is expression. So we will calculate land surface temperature by selecting band 10. We actually gonna calculate this land surface temperature, and this is the expression. And here you can see by that expression we calculated LST. So here you can see I printed LST minimum, LST maximum. So here you can see these values are actually the printed one, so 27 point, and here you can see LST maximum 60.5381 and different. So then I selected a different color palette. So here's then how I applied the function to get LST mean, mean, maximum and mean value, and then here I calculated standard deviation, which is very much necessary to define urban heat island map. So urban heat island map is that what we subtracted LST from LST mean and divided by standard deviation, which I earlier explained in urban heat island formula. Here you can see I explained it earlier that UHI stands for LST minus LST means over standard deviation. So this way we will get our final urban heat island index or urban heat island map. So this is the function that I applied, and for urban heat island like UHI minimum and maximum, I applied function to set it auto. So you don't have to like set it manually. It will be automatically selected, and visibility is also set to as auto. So it will automatically adjust minimum and maximum. So after that, here you can see I applied function reducer to get printed all the values: LST, minimum, maximum, standard deviation. And here I applied legend to get like a beautiful legend thumbnail in map layout for enhanced visibility. You can see over here, here's the way. And then I applied my channel logo, learn geography JS RS with AI. So please don't uh, forget to subscribe my channel. And here I explained that how positive value is affecting. So you can see the positive value confirms that the presence of urban heat intensity. So you can sense that positive value indicates that there is a comprehensive measure of UHI intensity. So you can see there is quantitative measure, and 3.8 degrees. So that positive degree defines that there is effect. And here the finally I added export functions to get the final export file. And today I'm going to show you full this practical, and I will load this in ArcMap. So I already downloaded the file, I exported and downloaded. Here you can see I'm just going to show you the properties. It's 14.79 MB. I just downloaded, and here you can see I already downloaded to save your time. So this is our map which I am going to design in ArcMap further. So here you can see our maximum and minimum value. So and we got, and here is my shapefile on which I'm gonna load that urban heat island file that I just downloaded. So let me locate my file. So this is my shapefile. Yeah, here is my file, that UHI final map. So here you can see it's 14.79 MB that I just downloaded today. You can see. Now to save your time, I already downloaded. Just to save your time, now I'm just going to load this one in my ArcMap. And here you can see it's showing like this. So first of all, I have to extract it by mask. Then we will be able to generate same map in ArcMap. So first of all, we have to search extract by mask. So go to Windows, click on search and write extract by mask. So spelling should be accurate. Then you will get this option, extract by mask, input raster. So our raster in this case is TIFF file, which is UHI final map that we just downloaded. Then it put raster or feature mask. So we actually mask that Karachi boundary. So select Karachi, and then here you can select your output folder. So for example, you can select your any your output folder. So here my main motive is Karachi. So I'm selecting, or I'm writing just Karachi urban heat island map. So Karachi UHI, or you can create new folder and just paste your this Karachi UHI in that folder. So I'm just going to paste, and remember to put that extension. So its extension is TIF, which is actually raster format. And in environment you can set processing extent according to your shapefile. So in my case, my shapefile is Karachi, so I selected same as layer as Karachi. And coordinates, I'm also going to assign coordinate according to my shapefile. So it's better to give to assign it coordinates, so it will like be okay, and you will get your study area extent easily. So here I just applied extract by mask, and within few minutes it will give us our extracted area, and you can see extract by mask is completed. So this is our main final urban heat island map. So you can see that it's showing me the value 3.28 positive and minus 5.5. So we can compare these values to our mean max. So here you can see it's accurately given us the values that it's our maximum, and for low we can see our minimum value. So you can check these both values in ArcMap and in Google Earth Engine. So finally we exported successfully our urban heat island map to our ArcMap. Now I'm going to show you how you can like color this map, or how you can make layout in ArcMap. So you can simply go to symbology. Here you can see stretch order. You can just apply different colors to scenes. So here you can set any color of your choice. In if you want to keep range, you can select any color, and you can just create a range. So here you can see there are different colors that you can utilize. And here if you want to get that same map that we just watching in our Google Earth Engine, so you can also do that. Simply go to the classified option, and first of all we have to count the color that we assigned. So for example, if in my color palette I assigned around about 7 colors, so we can calculate them like 1 2 3 4 5 6 7. So it's around 7. So we have to select 7 classes. So for example, I selected 7 classes, then click on apply and OK. So it generated 7 classes. Now you can click color one by one. So the black one, you can see it's showing us range from minimum to maximum. So from color palette you can just give minimum color. So for example, our minimum color is blue. Just to assume, or just to show you, I'm just doing it just to show you. So for example, I selected blue. The second one is our cyan. So I just selected cyan directly, just to give you an idea, or just to create a visualization here. So how you can do, or how you can manage colors. So the next one is purple. So you can just directly assign purple, or if you want to like make it more accurate, just use any color picker extension and pick that color, and search over Google RGB code, and then apply RGB code in your ArcMap. So you will get exactly that color in your ArcMap. But here, just to show you, or just to give you a overlook, so I'm just doing it roughly, but speedy. So you can see the next one color is, for example, yellow green. So I'm just doing that. So our next color is like yellow. So I'm just going to give it next color is, sorry, red. So in our next class we can select red. So here you can see just selected red, and you can adjust any color of your choice. So for example, this is red. I just clicked on OK. And now just last class, which is actually our urban heat island class, that white one part. So we can select any class, any color here that will accurately represent. So I selected black just to give you an overview. So this is our final LST map. Now you can convert this into layout view, and you can further add legend, scale, north arrow. So for example, you can select full extent, and here you can add title, legend, and different things. Now I'm just speeding up the video to show you this urban heat island on different study areas and on different scales. So to save your time, I'm speeding up this video. And if you like, if you are new, and if you want to watch this, you can slow down this video. So I hope that you enjoying the video, and later I will show you this on different study areas. Here you can see I designed my urban heat map layout just to give you an overview, and I speeded up the video to save your time. So it was all about urban heat island map. Now I'm going to show you if we change values, so how we will get our land surface temperature. So for example, if the minimum value is 27 and the maximum value is 60, for example, if I want to extract that water body, so I'm just going to give you a trick that how you can extract water bodies also by utilizing this. So what I'm going to do, for example, our minimum and maximum is 27, minimum and maximum is 60. So for example, if I change this value to 20 to 40, so what it will do, it will give me that clear cut that water body, so I will be able to extract that. For example, I click 20 and 40. What it will do, it will turn all that area that lies under 40 degree or 40 plus or more than 20. It will create like one class for that area and one class for that water body. You know, water is always like a bit cooler than land in summer. If you talk for example, in summer, due to land differential heating, so you can see that land gets like more land gets heat like more quickly than water. So here you can sense that. So in that way you can also get water bodies, or you can try different values, or you can set, for example, you can for example, here I'm writing just different, or I'm writing just 27. So here you can see that it will just give me that water area from where the range is being start, and then the other area it's converting into the more than 40. So in this way you can also get that water body, or you can extract this layout, and you can get your only water area. So this is also a trick that I wanted to show you within this urban heat island map. Now let me show you to run this code on different study areas. For example, now I'm going to click this on Jammu, it's Kashmir region. So you have to keep in mind that in which months you get I mean to say you get summer. So for example, in Pakistan we get summer in June, July, August. So June, July are the hottest month. So but in Kashmir case it can be bit different, because there are some local factors that affect, like elevation, altitude, and other climatic factors that also alter, and also its position. But I'm just going to give you an overview that how you can utilize this code on different study areas. So I just changed the study area to Jammu region, and I clicked on run, and here you will see that it will give us the different. Now you can see that this actually this image is according to my previous range, so I have to select the accurate range for LST. So here you can see LST minimum and maximum. So first of all I will click copy that LST minimum range, just simply copy and paste over in your LST range in minimum, so we will get accurate our LST, so accurately visualization of our LST. So here I'm just like pasting the original LST minimum, and here is the maximum value which we will replace with the max value. So after that you will see that it will accurately generate me LST and UHI. So here you can see LST is different. Now I will click on run with new values that are accurate, and now you will sense that it's giving me uh, LST and UHI, which is actually our urban heat island index. So here you can see. Now you can also apply that trick if you want to extract that water body. You can just change your temperature minimum and maximum, so in that way it will like get you that water area, and you can also you can easily extract that water area. So it's also a trick within this. So here you can see that positive value also indicated that there is urban heat island effect, and you can see that urban heat island effect line in that with red color, that red, darker red color. So it's showing that there is urban heat island effect. And for example, if I change value -2 to, for example, 10, so here it will give me like two classes. Obviously that -2 will be on that water area or that mountainous area. So here you can see it's like there's it's like -2 was very little. You can hardly you can get area from here. But when we will change value, so we will able to get that which area is experience what kind of temperature. So you can set different temperature range to investigate that which area is getting what kind of temperature. For example, water bodies are normally considered cooler, and mountainous areas, you at the top of mountain, you can find like more heat. Uh, and in valleys, so these values differ. So when I change the temperature range, so you can see how it's also manipulating our visualization. So by placing accurate values, you will get your accurate LST map. So here's how. And you can get this LST by different approaches. For example, you can also utilize different ready-made LST datasets, but here I just computed it on land surface temperature 8. So Landsat 8, sorry. So Landsat 8, you can also write expressions by two ways, or you can include BT, which is actually brightness, or you can calculate it top of atmosphere or without brightness. So there are different approaches that you can utilize. So for example, if I try this code, another area in Pakistan, which is Muzaffarabad, I just wanted to show you how values differ. For example, in Karachi case, it was like 27 to 60, and in Kashmir case, it was -2 to 54. And now let's try this on Muzaffarabad, a city over here in Pakistan, and it's also a northern in northern side of Pakistan, so will be bit cooler, and also there will be warmer areas. So let me show you how it differs for it. For example, I just change study area, change the study area. Now I just clicked on run, and here you will see that it loaded. Now first of all, I have to set the visualization according to the values that will be printed in my console. But here I'm just giving you an overview that this is our main urban heat island map for Muzaffarabad. You, in short, you can try this code, different study areas, and you can get urban heat island map. So here you can see the minimum is -4 and the maximum is 49. So for example, if I select minimum LST, and we will get accurate our land surface temperature map. So we have to replace that value. So I'm just replacing it with the accurate value for this area, and this maximum, just copy, and I'm just pasting over here in maximum value. And now I'll click run, then it will give me accurate urban heat island map and land surface temperature. Here you can see it's my final LST and UHI. And you can see minimum and maximum in urban heat island legend is changing automatically, and the range is also auto. And via this way you can sense urban heat island map. So if you found this video helpful, so please subscribe to my channel if you're new, and I hope that you enjoying my content. I'm trying to bring something new and to help the community. And if you want this code, just simply mail me at notes, just simply write down your mail below comment, or just ask me or request me for mail. I'll post my mail and I'll send you the code. Now I'm just trying going back to my area for which I actually calculated this. So here you can see I'm again moving back to Karachi, and the range is it differ, so that's why it's giving us that kind of LST. So when I will select the accurate range, so it will give me accurate Karachi map. Please subscribe to my channel and have a nice day. Enjoy the video urban heat map. Thank you. Bye.